Hi, and welcome to this video on problem solving. We have a diagram with numbers. Some of those numbers are in braces, like 15, 11, and 20. And we have that the numbers in braces are the sums of the adjacent numbers. So for instance, 15 is 3 plus 12. So there we have that. And we have 3 plus 8 is equal to 11. And then we have this other pair of numbers adjacent to 20. We have 8 and 12 that add up to 20. We need to duplicate the pattern to complete a new diagram. The new diagram contains various numbers. Some of them are in braces, and actually the ones that are not in braces are unknown. We have the numbers 33, 22, and 27 in braces. And according to the previous diagram, we can see we need to find numbers here, here, and here, so that 33 is the sum of the adjacent numbers, the one right here and the one right here. So let's use some colors to right here, that this number added with the number we put here, which we don't know yet, should be 33. And there, another pair of adjacent numbers will be this one right here. So we need those two numbers that we don't know yet to add up to 27. And finally, we need these two numbers to add up to 22. The answer to this problem would be the numbers that we don't know, and there are 3 of them. And to solve this problem, we can use different strategies. There would be many strategies that can be used. In this video in particular, we're going to cover solving this problem using the strategy of guessing and checking, and then we're going to use the strategy of introducing variables. Okay, so let's start with guessing and checking. So here we write solution through guessing and checking. There are 3 numbers that we need to find. Those numbers vary a lot, and with the strategy of guessing and checking, we just start trying some combinations out. So we will have many combinations to try, but one thing we can potentially do is draw a table with the combinations we try so that we keep track of what we have done. And once we find a good combination, we are done solving the problem. Now, because there are 3 unknowns here, we're going to write a table that has 3 columns. So let's draw this table with 3 columns. And there are 3 unknowns. Let's call one of them A. So let's say lowercase a. The one right here is going to be lowercase b. And this one right here is going to be lowercase c. We're introducing variables. We're not going to use any algebra at this point to solve the problem, but we just introduce variables to have a clear idea of the values each of the variables is going to take. We have a distinction between a, the number that goes in between 27 and 33 in B and then in C. And we can start giving values to any of the variables. We would see it's enough to assign one of those variables a value to find the other two. So let's start with B. Just for instance, you could start with A or with C. If B was equal to, say, 1, and we're picking positive integers, counting numbers, so 1, 2, 3, 4, 5, 6, 7, and so on, based on the diagram we have above, that's the kind of number we want to work with. If B was 1, then we would have a 1 here. We would need to have that whatever we put in A added with 1 gives us 27. The only possible choice for A is 26. 26 added with 1 gives us 27. Okay, so by fixing B arbitrarily, we have found A. And then we can also say that, based on this diagram, B plus C, the addition of the sum of those numbers right here, should be 22. So we need a number C that satisfies that when it gets added with B, and B is 1, we get 22. The only possibility is 21. So for this particular guess, we are assuming B is 1, we're getting A equals 26 and C equals 21. Now, we need to be careful. Let's see if the diagram we got with B equals 1 is a good diagram. We have 26 plus 1 equals 27. That checks out. 1 plus 21 equals 22. That checks out. But then there's a problem. 26 plus 21 is not equal to 33. So we have made a guess that does not work. B equals 1 is not possible, because if we chose B equals 1, A would have to be 26, C would have to be 21, but then A plus C would not be equal to 33. So then this guess is not good. And we go back to square one and try a different guess. We can try different values for B. I'm just going to choose 2 next, just because it's the number that comes right after 1. With 2 for B, we need A, so that A plus 2 is 27. A will give us 25. And then we need to find C, so that C plus 2 is 22. That would give us 20 for C. With a 25 here and a 20 there, we would need, then we would check 25 plus 20, that's 45. That's not equal to 33. So this is another guess that does not work. So B equals 2 is not an option. We would continue with many guesses like this. Our next guess could be B equals 3. So with B equals 3, we continue, checking for values for A and C. A is going to be 24. We can see a pattern here from 26 we went to 25. It makes sense that we go from 25 to 24. Here from 21 we went to 20. Here it makes sense that we go to 19. And we could check that out. 24 plus 3 gives us 27. 3 plus 19 gives us the 22. But then when we add A and C, 24, right here, plus 19 that's definitely larger than 33. So that combination is not going to work. And we continue like this. It turns out that after several attempts, we make it to an answer. An answer will come from taking b equals 8. b equals 8, we get to find a, so that a plus 8 equals 27. And a possible a, and the only possibility for a, if b is 8, is 19. And then we need to choose c, so that c plus 8 is 22. And that number is going to be 14. And then when we add a and c, so our value for a is 19, and our value for c is 14, we get to 33. So we have 19 plus 14. 9 plus 4 gives us 13. So 1 gets to the other column, and then 33. All right. So by guessing and checking, we have found a solution to the problem. We have found a possible configuration that follows the rule, the same pattern that the diagram here follows. So 8 for B, that would be the right answer. So here we have 8. And then we have 19 for A. And then we have 14 for C. And this is going to be the answer. Okay. So this is one way of solving the problem. We guess and check. Next, we're going to use a different strategy to solve the same problem, to find 3 numbers. And we have labeled them A, B, and C, so that the diagram follows the same pattern the diagram that was given follows. So let's move on to a new page. And I'm going to copy the diagram right here and paste it there. So let's start the solution through algebra. And we start with the problem as it was given. So there will be question marks everywhere. And we'll actually go ahead and use the variables A, B, and C, just as we used them before, to set up this problem algebraically. Okay, in order for this diagram to follow the pattern the diagram that was given follows, we need 3 things to happen. We need A and B, the numbers adjacent to 27, to add up to 27. That can be written as A plus B equals 27. A second equation follows from imposing that B and C, the numbers that are adjacent to 22, add up to 22. And finally, we need whatever goes in A and in C to add up to 33. These are all the conditions we need to impose on A, B, and C. And there are 3 conditions in total and 3 unknowns. So A plus B equals 27, B plus C equals 22, and A plus C equals 33. What we have right here is a system of equations with 3 variables, and it's a linear system We can solve this system by, for instance, using elimination or substitution, or there are various tools we can use. One thing we can potentially use is the following one. Notice that once B was fixed, we could find A and C. We exploited that idea as we solved the problem through guessing and checking. So if we were to fix B, and we know that we don't have B fixed at this point, but if we were to fix B, we would be able to find A and C because here A actually comes from taking 27 and subtracting B. Whatever B is, we need A plus B to be 27 from the picture right here. So as we solve for A, we find that A must be 27 plus B. We also used that once B is fixed, C can be found because B plus C should be 22. So if B was fixed, we would be able to say that C would be 22 take away B. We can see that equation coming from solving for C. And another thing we did as we were guessing and checking is that once we knew the values of A and C, we added them up to check if we were getting 33. So we take those values that we have for A and C, written in terms of B, and we have that A plus C should be 33, but A is 27 minus B, and C is 22 minus B, and that should be equal to 33. And we're getting an equation in terms of one variable only. We're going to find B this way. Because 27 minus B plus 22 minus B should be equal to 33. We should have that 27 plus 22, and that's 7 plus 2, that's 9, and then 2 plus 2, that's 4. And then minus B, that's minus twice B, should be equal to 33. We're collecting like terms on the left-hand side of the equation. And we're trying to isolate B. To isolate B, we can add 2B to both sides of the equation. So we get 49 minus 2B plus 2B equals 33 plus 2B. Here on the left, minus 2B plus 2B go away together. So we end up with 49 should be equal to 33 plus 2B. And we're trying to isolate B. So let's get rid of this 33 besides the 2B. We're going to subtract 33 to both sides of the equation. So we get 49 minus 33 equals 33 plus 2B minus 33. What we do to the left-hand side gets done to the right-hand side. 33 minus 33 is 0. So we end up with 49 minus 33. We can compute that. There is 9 minus 3, then 4 minus 3. So 16 is twice B. And if 16 is twice a number, then that number should be 8. Or same thing, we divide both sides of the equation we just got by 2 and get that 16 over 2 is 2B over 2. So B turns out to be 8. So B is 8. So here we will have an 8. And to complete the diagram, we need to find A and C. So we go back to these equations right here, because A could be found based on the value of B. We have A equals 27 minus B, but now we know that B is 8. So we do 27 minus 8, and that gives us 19. And finally, C should be equal to 22 minus B, and we found that B is 8. So we end up with 22 minus 8, and that gives us the value 14. So A is 19 and C is 14. We end up with the same diagram we found as we guessed. So A is 19, B is 8, and C is 14. Okay, so this is an algebraic way of solving this problem because we have 3 unknowns. We introduced 3 variables, A, B, and C. All right. Thank you for watching this video. If you have questions, let me know. Bye-bye.